Welcome to Collections and Streams. In this section, we'll start by looking at how to define collections, and specifically map, set, and list. Kotlin actually has an immutable as well as a mutable type for each of these. We'll look at how to loop over collections, and you'll learn about eager versus lazy evaluation. You'll see how to filter a collection and apply discriminator functions, and even how you can find one or more objects inside of a collection. Kotlin has special support for range types, so we'll see how to iterate using ranges and how they relate to arrays, as well as how you can create ranges from numbers. Lastly, we'll look at a very popular paradigm called Mapreduce, which is all the rage in the functional world. And this mechanism can be used both to transform collections from one set of items into another, but also to transform that whole collection into a new object. In this video, we'll look at how to define and access collections. We will create instances of list, set, and map, both immutable and mutable versions. Kotlin really favors immutable collections, which is evident by the names given to the functions used to create these collection objects. You should also know that read-only list types are covariant, which you'll see in a second. Let's define some collections. We'll start with a list of ints, and we're going to call it numbers. So we'll use the list_of function, and we don't need to specify the type since it can often be inferred from the parameters. So let's instantiate this list with 1, 2, 3. You can see that the type hint shows up and tells us that this is a list of int. Now this is immutable, so this list is going to stay the same forever. Let's create a mutable version instead, and we call that mNumbers. And to create a mutable list, just add mutable in front of list_of. So mutable list_of creates a mutable list of int. Now sets are created in the same way and are treated mostly the same as well. So you would write set_of instead, or mutable set_of. Let's move on to maps instead, because they're much more interesting. So let's create a map of names to ages. So people will be a map of. And let's look at our alternatives. We can pass in one or more pairs of kv. So pair is kind of a tuple object which can contain two values, one key and one value. If you remember, we talked about data classes. This pair object, let's have a look at it. So we'll find Kotlin pair. You can see that it's defined as a data class, meaning that it's going to have the component 1 and component 2 functions. And the values themselves are also available using first and second. So when we create a tuple of pair, so we will give it the key first, so that's going to be a name. And then the second parameter is going to be the value. However, you can create pairs in a much nicer way by using the toInfix function that comes with the standard library. So let's add Jill, and we're going to set her value to 24. And you do that with the toInfix function. So this kind of looks alien, and you might wonder if this is handled with some special souls only for a framework or for standard functions that comes with Kotlin. But you can actually do exactly the same in your own functions and APIs. We're going to look at that later when we tackle infix notation. For now, it's good enough to know that this is one way of creating pairs and this is another. Again, this list is immutable, so to create a mutable list map of people, we would write mutable map of instead. So let's see how this behaves at runtime. So let's try to add an int to the numbers list. You can see that list simply doesn't have an add function. So let's try it on the mutable list instead. There it goes. You can't really run into a situation where you call something and then it fails at runtime. The type system will make sure that you don't make any mistakes when it comes to mutable versus immutable. Now for the map, let's try to add a third person to our people map. So you're used to the put function from Java, and you can't even find the put function on a map. So let's move on to the mutable version instead. And here we have our put call and add another person. So this works, but Kotlin has a much nicer way of accessing values in a map. So we can instead use bracket notation for the key and then simply assign the value. So So this cuts down on boilerplate and makes it easy to read, really. You can also extract values in the same way. So you can say mpeople, then access Bob. You should also know that if you extract something from a list, even though the list types, the value types are not nullable, if you extract something, it's going to be declared as nullable because maybe it doesn't exist. So let's try that to extract, for example, Jill's age. So that would be people and then Jill. You can see that the type is int question mark. So if you remember the shoot yourself in the foot function, that's always available to you. Now the type is int, but this might fail at runtime. So let's leave it like this. I mentioned covariance in immutable collections. So let's look at that. And to show this, let's introduce a hierarchy of classes. So we'll create an open class called shape, and then a class that extends shape that we will call rectangle. So it's going to extend shape and call the primary constructor of shape. Now we can create a list of shapes or a list of rectangles. Let's start with that. So that's a list of, and then we'll instantiate a single rectangle. So if you look at the type hint now, this is a list of rectangle. Now we could now define a list of shapes as list of shape and assign the rectangle value to it. This is perfectly fine. However, if we create mutable rectangles, so that's a mutable list of our rectangle, and then try to create mshapes the same way by defining it mutable list of shape and assigning mrectangles, this won't compile. So let's hash it out and look at how that is implemented for a second. So let's jump over to list. You can see that the type parameter for the lists is declared with the out keyword in front of it. And that means that the list is covariant on its element type. If we jump over to mutable list, you'll see that it's invariant because it's missing the out parameter there. So we're going to look at this more closely later. Just wanted to show you once again that there really is no magic here. It's just a clever usage of language features.